So today is Thursday, and I'm doing this out of sequence. There is really a job in front of this, but it seems sensible to do this first because we're already pretty well set up for this. And that is because it's another Maxcom set. We had the Consam 1320, we had the 16E, and now we've got the smallest one they did, the 20E. And of course the 21E is the same radio but with a fairy light meter instead of a conventional meter. These usually do what they say on the tin. Let's just check it's got the right fuse and not a hair grip in it. 2 amps, that's right. And we'll connect that to the crocodile clips that I love shorting out. It's rare we do a video without shorting out the crocodile clips. But we have the advantage that the power supply is set to cut out at 1.2 amps. It's got a little bit of dirt on that switch. So I've got about 3 of these on the shelf. I nearly did one yesterday rather than the 16E, so I'm glad I didn't. So let's see how it's performing. So it says May 1982, so it's the later batch. Just need the instrument speaker. Just like that. Factory original mic. These radios were guaranteed for 2 years, and the mic didn't come into the guarantee at all, and most lorry drivers had crushed it within 10 minutes. So it's nice to see one that has survived. So on these it isn't a locking din. Right, switch picture in picture on. And let's look at what the power is. So I'm going to put it on the 3 watt scale. So full scale deflection would be 3 watts. Okay, so we're on low power, and low power is doing 280 milliwatts. Switch to normal, swung across, it's doing 3.2 watts. So TX 3.2 watts. Let's look how on frequency it is or not. Yeah, it's just dropped a little bit. That's neither here nor there, but we will bring it up. 27,79103. So let's look at receive. Oh, we'll look at deviation. 1, 2, 1, oh, 3.8. Which is ridiculous. I know what they do, these screwdriver experts. They've got a radio on their so-called bench, and they twiddle it, and their mate, you go, how does it sound now? And the mate's listening on a Fidelity 1000, and it sounds great when it's doing 3.8 kilohertz. Or how about 15 kilohertz like the Maxcom 16E yesterday? But then you get somebody with decent filtering on the radio, and it's trying to get a fat guy through a small door, and it has to cut the edges off, like if I went through a small door. So, receive. Just set that. It's not being used today. Right, there we go. So let's go over to the cyanide meter. And we'll adjust the attenuator controls of the signal generator until we get 12 dB cyanide. And that's 12. So I'll switch that now over so you can see. So we've got the big hand on one. It's like nearly to read the clock. And we've got it's on 0.75. So it's doing 0.75 microvolts for 12 decibel cyanide. Now that's not remarkable, but it's adequate. Good. So now I'll open the setup. So pause the video while we do that. So at this stage I don't really feel I've got to unsolder the speaker because there's enough wire on the radio, and I would think this is just a retune. I don't think there's any reason to be thinking there's any fault with the radio. So we'll put it back on. Start with the transmit. And it's more or less what we had with the Consam 1320 a few days ago and the Maxcom 16E yesterday. So into transmit we go when I put the camera back to the appropriate meter. So 3.2-ish, 3.4, something like that. So we'll just peek that one. That was already spot on. And that one. And that one. This doesn't look like it's ever been touched as far as power goes. I'm going to have to put the spectrum analyzer on because after yesterday I adjusted this one and ended up with a harmonic I didn't want, so we'll need to check for that. I'll just loosely couple the spectrum analyzer. I'll put that on the screen instead. So I'm going to put 55 megs in. At the moment, I can't see anything there. So I'll now press auto, let it scan, and let's see what we've got. It's a lot of power at 333 megs. We'll end up talking to military aircraft on that. I'm going to see if it's still there if we go to low power. It is. So what I'm going to do is I think we'll connect the spectrum analyzer directly on low power through an attenuator. And see whether it's that which is affecting it. The answer is no. We'll just retune that now. We'll just go back to low power. And we'll do an auto scan again. So the proof of the pudding will be the eating, and of course we'll do a scratchy corner test to make sure that it is all transmitting where we want it to be. But I thought I would double check on this occasion after yesterday's. You just don't know what's being fiddled with on radios that are 38 years old. Right, let's pop it on frequency. That'll do. It's just a couple high, just so that it's got room to drop, which should drop with age. Deviation. Get the oscillator out. It's going to be Squelch, isn't it? Not sure where the adjustments are on this version. It is the deviation there. Wallow, that's still a bit high. One, two, wallow. That's 2.2 to 2.5 absolute peak, which is where we want it. So that was deviation. So let's do the transmit meter, banging across. So it's probably one of these. So that's now showing 4 on the meter. Absolutely banging across before. So, you know what, I think we've covered transmit now. So we'll do receive. So we'll drop that to 4 dBs on there. So I'm putting a 0.52 kilohertz signal to it, 0.52 microvolt signal into the radio. And now we'll go through the front end. You know what, so far that's spot on. Let's put a big signal on it and we'll look at it on the oscilloscope. Just do the detector, take the bench light off, or the discriminator, whatever you want to call it. Gain diffraction there. Let's go back to the synod meter. Now that one was out. just go through these again. Yes, that's about where we are. Let's see what figure we're now getting on that synod meter. So that's about 12 dB, and the radio's doing 0.74 of a microvolt, so we've actually gained nothing. But it's in spec. It will be better because the detector's set better. We've done that. We've done that. We've done that. We've done that. So that leaves us with setting the S meter. So it's S9 is 100 microvolts on a UK CB radio. And it's pegging the needle, but of course I've been messing with the presets. Expect it's that one. No, what's that one then? Perhaps there isn't one on the meter. It's going to be low power and Squelch. Is that one down there? Yeah, the S meter is going to be that one down there in the naughty corner. It would be if it moved. Get the metal tool for that. Interesting. So that's not affecting it. So what's that affecting? Let's look at low power. So is that low power? Yes, it is. So that's now set to 400 milliwatts. So that now leaves us with that and that. So one's going to be Squelch, and the others must be S meter. So I'll put a bit less signal on so it's more obvious. Yes, it's that one. But it doesn't quite adjust where we want it to, I don't think. That's because the needle's a bit sticky. That's what caught me out. There we are, S9 for 100 microvolts. So it's transmit meter, receive meter, low power, deviation, and that's going to be Squelch, and that's our next port of call. I like it to be 100 microvolts. That's Mr. Chippy sneezing that came across. Well, that's not squelching. That Squelch is never coming in. So I've got this on full Squelch. Let's look at the attenuator. That's on full whack on the signal generator. So the Squelch is never coming in ever, which is pretty useless. That's right, 100 microvolts it's coming in at. So now we'll do the opposite. So we'll turn the signal generator to 0.3 of a microvolt. We'll park it in that position, and it's now on standby. Turn the squelch down and set that to threshold on the radio. Take that out. Switch the signal generator back on, and let's see when the squelch comes in. And the answer is the squelch is coming in at 0.27 of a microvolt. No, it's not. Totally lying. The squelch is coming in at 0.9 of a microvolt, and it's leaving at 0.45 of a microvolt, so it's got a good squelch range. Now we've said the sensitivity was 0.74 of a microvolt for 12 decibels cyanide, but how can this radio hear? What does it hear down to? So there's, I've turned the squelch down, there's 0.3, we can still hear that, 0.25, 0.2, I'll lose it about just under 0.15. So it is very sensitive, but not as sensitive as the freaky one yesterday, which was that Maxcom 16E. So that's everything, we're all done. So subject to that being okay on the scratchy corner test with Mr. Chippy, that should be good to go. Now I'm not going to put switch cleaner into that switch. I've waggled it around. They're self-cleaning because of the way the contacts are. So it's not come back with the display. It really does need some... I'm trying not to have to put switch cleaner in that, but I think I'm going to have to. I'll take that one screw back out again. If you worked it around enough, it should clear itself. Oh, you can't get to it from this side. I don't want to do this from... I don't take the front off this because that opens a whole nother bag of worms. So the trouble is when you're using the switch cleaner, it's going to drive out some of the grease. So you then end up with a stiffer control. So it wasn't wildly out, but it certainly needed looking at. It's been distortingly loud on a decent radio. You know, people would have said, "Oh, you're breaking up," which is what would have happened. Anyway, it's got in there and it's working. Right, we'll put it on the aerial and we'll see what kind of people are out there. Bearing in mind we're 35 miles from Nottingham, 32 miles from Lincoln, 32 miles from Boston, in the middle of nowhere. So apart from a few farmers and quarry workers, Okay, here we go. I'll take the external speaker out. We may as well turn off the test set. One nine one on a Roger.
Roger, Bray.
Thank you, Breaker. What's your 20? I'm at Ancaster.
I've just come out of Wilsford heading towards Sleaford, Bray.
Yeah, 10-4 on that. Thanks, good buddy.
You're welcome, mate.
Excellent. So, he's about 4 miles away, about at the where we do the test, and he's on that road, and he is about just past the Kelby turn. Good. Well, we don't often get a Roger, do we? Well, that was all right then. So we'll see how that goes with a test with Mr. Chippy, where everything's calibrated and we know what results we're expecting. So thank you for watching. The customer's Maxcom 20E realignment works a treat.